You are driving across a bridge that engineers already know is slowly failing. Not collapsing today, probably not tomorrow, but inside the concrete, tiny cracks are spreading. Water is leaking in, steel is rusting, and every year the structure gets weaker from the inside out. Now here's the part that sounds fake. Humans already discovered a way to make concrete heal its own cracks. Over 2,000 years ago. And the ingredient costs less than a pizza. Back in 2023, researchers at MIT published a study that reopened one of the biggest mysteries in engineering. Why is Roman concrete still surviving after nearly 2,000 years, while modern concrete often starts breaking down in just a few decades? Think about that for a moment. The Pantheon in Rome is still standing with the world's largest unreinforced concrete dome, nearly 2,000 years old. No steel skeleton, no modern chemical additives, no repair crews patching it every spring. Meanwhile, in America, parking garages, bridges, and condos can start showing serious structural damage before they even hit retirement age. So what did the Romans know that modern engineers forgot? At first, scientists thought they already had the answer. Ancient Roman concrete contains tiny white chunks scattered throughout the material. For decades, researchers assumed those pieces were just mistakes. Bad mixing, low-quality construction, basically ancient contractors cutting corners. But MIT professor Admir Masick looked closer and realized something didn't make sense. The Romans were master builders. These were the people constructing aqueducts, harbors, and domes that still exist today. Why would they suddenly get sloppy with the most important material in their empire? Turns out, those white chunks were not mistakes. They were the secret. The Romans used a process now called hot mixing. Instead of dissolving quicklime in water, first like modern cement production usually does, they mixed quicklime directly into the concrete at extremely high temperatures. That created tiny pockets of reactive calcium trapped inside the material. And this is where things get crazy. When cracks form, water enters the concrete and reaches those calcium pockets. The material triggers a chemical reaction that creates new calcium carbonate crystals, basically fresh limestone growing inside the crack itself. The crack starts sealing naturally. MIT researchers actually tested this in the lab. They cracked Roman-inspired concrete samples, ran water through them, and watched the fractures seal themselves within weeks. Modern concrete samples? The water kept flowing straight through. Now before anybody says, then why isn't every road in America made from Roman concrete? The answer is simple: speed. Modern Portland cement became dominant because it hardens fast, works well with steel reinforcement, and fits modern construction timelines. Contractors can pour it quickly, cities can build faster, developers make money faster. Roman-style concrete can take much longer to fully cure. And once an entire industry builds around one system, changing it becomes incredibly difficult. But the cost of that system is starting to show. In 2022, Pittsburgh's Fern Hollow Bridge suddenly collapsed. Luckily, nobody died, but investigators pointed to years of corrosion and deterioration. A year earlier, the Surfside condo collapse in Florida killed 98 people. Investigations revealed severe long-term concrete deterioration and water intrusion issues. To be clear, concrete alone was not the only factor in these disasters. Structural failures are complex, but aging reinforced concrete was a major part of the story. According to the American Society of Civil Engineers, tens of thousands of U.S. bridges are still rated in poor condition. Many are operating far beyond their intended lifespan. Here's the scary part most people never think about. Concrete looks solid from the outside, while slowly failing internally. Water gets in. Steel rusts, rust expands, the concrete cracks wider, more water enters, the cycle keeps accelerating year after year. Roman concrete behaved differently. Researchers studying ancient Roman harbors discovered that seawater actually helped strengthen some structures over time. Minerals formed inside the concrete and reinforced it naturally. Modern concrete does almost the opposite. Salt water destroys it. And there's another massive problem. Cement production creates roughly 7 to 8% of global carbon dioxide emissions. If the cement industry were its own country, it would rank among the world's biggest polluters. So longer-lasting concrete would not just save infrastructure, it could also cut enormous amounts of carbon emissions. That's why researchers worldwide are now racing to develop self-healing concrete inspired by Roman chemistry. Some teams are experimenting with bacteria-based concrete. Others are testing advanced limestone reactions and self-repair materials. An MIT-linked company called Diamat is already working on lower carbon cement systems inspired by ancient Roman techniques. But even if the science works, changing building codes, construction standards, and billion-dollar supply chains could take years. And honestly, maybe that's the strangest part of this whole story. A civilization without electricity, computers, or modern machinery may have created building materials durable enough to survive for millennia. While some of our modern structures are designed around lifespans shorter than a mortgage. Maybe the future of infrastructure is not inventing something completely new. Maybe it's realizing the ancient world already solved part of the problem, and we just stopped paying attention.